It's okay. Good morning to all. Thank you for being here today in Milan. This is, I think, a short presentation about RouterOS firewall. If it's possible, I try to do a little presentation about this kind of part of routers that is, I think, misused by most of people because it's complex, it's not easy. Then, I am Massimo, I'm from Italy. Then you can call me also Max. It's for other people, also for English people, it's easy. I am owner of my company, Progetto Archivio, that is in Turin, and also Decobit, that is a service provider, voice provider in Turin. I'm a system engineer, and I'm system architect. My work is optimization of platforms, systems in general, also networking. This is why I am also MikroTik trainer, and I do certification. Okay. First of all, the last year I was in Ljubljana, and I made a talk about switching. I know that this evening there is a talk about switch, but I want to do this for MikroTik guys that after the MAM do this kind of implementation. My request was about adding hardware spanning tree on the RouterOS platform, because on switch chips there is hardware spanning tree, but at the moment we can't enable this function. Then from the 638 we have this function. This is only a reminder to make sure that all people know that today we can enable the spanning tree. This is a short procedure. We make a switch, add master port to bridge, and from the bridge menu, if spanning tree is enabled, also is enabled on hardware. There is, on my presentation, there is the link of the wiki of MikroTik, where is well described this is most important feature that MikroTik added to the RouterOS devices. It's very important. Then, let's go forward. Today, goals. I want to explain to all people, every people that also doesn't know nothing about firewall in RouterOS, where is it and what you can do with it is very important. And also, it's very important to make focus on the changes that firewall has in the last year, because they are very important changes. There is something missing also, but it's a good step forward. And there are two examples, one small, simple, but powerful, and one more complex. I want to do this. Then, just to look forward, we go to the last. This is one of the last slide. This is the end of presentation. This is the focus. Complex firewall, this is the second example. Configuration can be exported and imported to another router board with no error. This is a goal, to maintain a number of devices, not one, more than one. And specific configuration that was SSH filter, ICMP filter, or other kind of this configuration can be cut and passed from one device to another without having no error. Is very important. Then this is the last line, recycle firewall rules, because today if you write a rule with specific configuration, you must write from scratch in one other device. This is the goal. To the start. Then, what is a firewall? Very fast. Try to isolate less protected outside area. It's not important outside, inside, but it's a common definition. From more protected inside area. It's quite simple. Then, it's a security device. I call device because normally you think about firewall like a device, but in the RouterOS is only a component of the RouterOS system. Then this is important for school. Security is a process, it's not device. You must implement something else to have the security at network level. And the last line is more important. The less secure item is between the keyboard and the chair. The man is the problem. So we need to have device systems and all things to protect the network, but from the human. Don't forget this. Then, this is the most powerful firewall that you can have in your network. It's difficult to read because it's small that could here to activate firewall. If you cut the rope, there is no network. This is level 1 firewall. Just kidding. Then, the firewall in a RouterOS device can be also level 2 firewall. It's more important. This is one important thing that if you kill the packet at the first site, when enter the RouterOS, this is a good job because each step in the RouterOS make some CPU consuming things that slow CPU and can do something nasty. So if you early kill the packet, this is the best choice. L2 firewall can be achieved by bridge or switch. Switch also by hardware, so you can do ACL on the switch and kill kind of traffic, obviously. Level 2 traffic, so MAC address. We don't talk about that today. My goal is to explain level 3 firewall, that is IPv4 and IPv6 firewall. You have also one function that is misconfusing, web proxy, because it's used as firewall for HTTP application, but is only a reference. Then, this is what I said. Okay. To understand well where is the firewall in RouterOS, you must look at this graph. It's a little confusing, but it's a good reference because in this graph we have, we have physical interface, physical in interface, out interface, logical interface. Is a complete graph of the packet flow inside RouterOS. But it's a little complex. This is another representation of the packet flow, but is more traffic oriented and is simple. Pre-routing, input, forward, output, and post-routing. And there is all items that do control of the packet flow, in the packet flow. This is my favorite. Oops, yes, it's done. Okay, this is simple and big. I want to do that because I want that all people say this kind of representation. There you have input interface. You have all items that do packet, filter, mangle, connection tracking. There is all. And when a packet go to the RouterOS device, if they go to the device, do this kind of path. If it's exiting from the RouterOS device, go from here to here. And if it's forward, go from there, there, and there. It's quite simple. It's very important because the order of the dock is very important. We have the route routing, hotspot, connection, mangle. This is the order where the packet go to the RouterOS device in this order. First of all, we need to talk a little about connection tracking. Connection tracking is a way that all operating systems that do networking goes to. Can be disabled also. But in the normal way, you have a system that detects the connection at network level. Even TCP UDP is not so difficult to understand what is the connection. In TCP, there is a logical connection about TCP. In UDP, when you open UDP connection, you have connection. Well, there is no state, but in the TCP connection, you have also state. But in connection tracking, there is this kind of description. All connection can be new, established, related, but also unknown or invalid. I stop here because this is a more complex argument to explain here. But it's important to tell to all people that this kind of connection tracking is doing optimization in a firewall environment, because we can do a check only on new connection and ignore all other established, related, and also unknown or invalid, because we are trying to optimize the function of the firewall. And to do connection tracking in the normal world, and I'm talking about IPv4 because in IPv6 there is no NAT, we need connection helpers that are little applications that do connection tracking on complex kind of connection. SIP is one of the kind of connection. FTP is another connection, because FTP opens port side by the main connection and also SIP. That's all. Connection tracking is done at this level in the pre-routing and the output. So a packet that go to the RouterOS device go to the connection tracking in the input interface, and the packet that go from the output of the RouterOS device go here. You have only 2 points of connection tracking, and is near the start of the chain of the path of the packet inside the RouterOS device. Then it's important to say that packet flow show where firewall act. So in each position, something happens. Then each position is defined a chain. We see later that a number of chains that do the same thing can call it tables. And in each position, check and action, what is checked and what you can do are different. Because as we see, here you know what the name of the interface, where the packet is going in. Here you know where the packet is out, is the interface where the packet is going out. But you don't know where the packet is from inside or from the input interface. So in each position you can do different tests and also different action. So, and this is important for optimization. You can do jump and also return. This is important to make a complex rule without do more configuration that is unuseful, complex and unuseful. Filter table is the first table that I want to talk about. It's quite simple. The packet can pass or not. It's not only this, but it's more this. If you look in the RouterOS device, there is the position about IP firewall filter. And this is the position in the filter, in the packet flow. Input, output, and forward. This is a common default filter table. I want to do that because it's important to understand later. We have a rule that accepts established related connection tracking, drop invalid connection that are not new, established or related, are invalid connection because they are trying to pass the firewall without no reason. So after that, we have only to check new connection, and no need to check the connection state. And there is also other rules in default configuration. We go forward, we have an example to see later. Then we have NAT. NAT means network address translation, and this is most important, is only for IPv4. In IPv6, there is no actually NAT. And NAT is done at this point and this point. So at the end of the input interface, the pre-routing, and at the start, after the mangle of the post-routing. In the NAT, we can change destination address, source address, destination ports, source ports. All things about addresses is done at NAT level. Then this is the most complex things in RouterOS, mangle. In the mangle chain is done everything else that we don't do in the filter in NAT. We change, I think, everything of a packet. And this is most pervasive also. We have mangle here in the pre-routing, in the mangle input, the forward, output, and the post-routing. Then this is new item of the last year, the route tables. The mean of the route tables is try to do control of the traffic about in the packet flow early as possible. So if you see route pre-routing is the first one in pre-routing and is the first one also in output. Why you need row? You need row to do some nasty things about the DOS. If you are receiving a big quantity of data, you want to discard this. But if you put a rule in the filter forward, on the filter input, the packet go through hotspot, connection tracking, mangle, destination NAT, routing decision, and also other things inside the RouterOS. This is CPU consuming and also memory because the RouterOS system must do connection tracking. Dropping a packet in a route table means that you don't have connection tracking about this item. This packet disappears. It's very important. Then, how we can build a firewall configuration better? It's quite simple, but we have new item to use to do this kind of job. The first two are interface lists and address lists. Then we can use jump and return. And we can define also new chains. We see that later. And first of all, you must define less rules as possible, because more rules mean CPU waste. This is new feature. Interface lists was added to try to do some object hiding in a RouterOS firewall and also in other part of the RouterOS. But it's very useful to simplify configuration because you can define a group, not one only interface, a group of interface, and use a group of interface in configuration. So you don't ever need to put a physical interface name in the configuration of the firewall. You can use interface lists. We see later. There are, in the interface menu, lists. Interface list is the second. And we can add a list that is one, LAN, OSP, VoIP, one, Wi-Fi. This is example, so you can show that. And after, you can define lists. There is all definition that is predefined, and also the other. This is by definition. Then we have address list also. This is most powerful. Also for try to not put in the firewall configuration IP address ever. You must do that, but only on action and destination, in NAT. You can define a group of addresses. I think is mandatory for IPv6. If you know about IPv6 physical addresses are very long to write, and also there is also a big probability to make a mistake writing IPv6. And a big feature is as an action address. As an action, address can be added dynamically to address list, also with timeout. We say that later in the SSH filter. And this is a big improvement from the 636. DNS names can be used in address list. So we can put in address list also a name, not a physical IP address. This is very important also to simplify configuration of a firewall. Then, this is where is IPv4 firewall and address lists. You see this is example of address. This is a network definition, and also there is resolved name. This is definition, this is creation time, and also you can set timeout. You can define address and tell the RouterOS to delete this address after some time. This is useful for firewall filters to detect brute force attack, I think. This is DNS name resolution. You see this is the name, and then there is dynamic added address with resolved IP. That's dynamic. In the IPv6 is the same things. You say that is is here address list is the same things. Then where we can use lists. The best place to use list is in firewall rule. It is not important where. NAT, mangle, filter is not important, but in the definition of a rule, you can do this kind of job. You can put in interface, out interface. This is physical interface, or you can add in interface list and out interface list. It's the same. This is sample of one. Then, for the address lists is in the second tab of the firewall rule, not general but advanced, and you have the ability to put source address lists. You can choose one list, and for source, one for destination. And this is a way that you can write IP address in a configuration of the firewall. Okay? Then, this is also a list of features that are being improved in the last year. Because not all people use this kind of limits and feature in a RouterOS, this faster connection limit is classification rule. You can check where there is too much traffic, too much number of packets, number of bytes that go through one rule. And the other, we just say, check the wiki for update, because these kind of features are near present in RouterOS from years, but MikroTik guys do optimization, less CPU overload of connection limit check. This is very important to use dynamic address lists to check the DOS also. Then, this is quite simple example. You know what is routeback? It's a feature that is not present in many other vendors. They doesn't know how to do that. But in Linux and also in RouterOS, it's possible to do that. I have internet connection, IP address on the router. This is LAN network. I have B IP address, C IP address, and D IP address. This is a server. Email server, HTTP server is not important. You want to have a PC, a laptop, that go outside the network and connect to a DNS name of IP address. Email, it's standard things. You can do that by doing change on DNS. When you are outside, the DNS resolve the public IP address A. When you are inside the network, the DNS resolve the private address D. This is common configuration of most vendors. In RouterOS, we can do more. You can use the same IP address. You can do that. The PC call the router do a destination change, the packet go to the server, but if I leave the connection by this way, the packet has source address of the PC, so the packet go directly to the PC. This is not right. This broke the TCP connection. So to do that right, you must also in the router change the source address of the packet, so the packet go back to the router and then go back to the PC. This is routeback. It's quite simple, but what happens if you have dynamic IP address? You must do destination change based on the public IP address. You can do that with DNS name. It's quite simple. You can use cloud function of a RouterOS. So the device register on the network and have DNS name. Then use in the address list the public name to map the destination NAT change. We can see then. This is the start. We have the definition of the address list. Cool name, mam.it. This is list. We have a set of default rule. Then we have in the second page, okay, this is the most important. We have masquerade of the PPPoE1 connection for the outside traffic. And this is the destination NAT that do use address list to make connection to the server inside the network. And also there is this that is the source NAT that is doing the thing that I say before, changing the source address to make sure that the packet go to the router, not directly to the PC. If you see that, we use 2 times the destination address list, and also we use in the first page, in interface is later. Okay, I don't remember this. But if you want to build a complex firewall, don't think about what you can do. It's important that you have one-one connection and more logical inside connection. You have LAN, VoIP, Wi-Fi, a lot of things. And if you use a standard way to write rules on MikroTik RouterOS device and firewall rules, you do a lot of rules because you have a lot of interface, lot of ports, lot of hosts, lot of many things. Then we can show that in this is the configuration. This is real firewall, IP, firewall. Then we have filter rules. And this is the first step. The input rules, you say that input. And you say that the first 2 rules are default rules. Accept, establish, related, and drop invalid connection. Then we have 2 common rules. The accept of ICMP, and this is, I can't read the destination port, but this is TCP connection for the management of the Winbox. Then we use jump. If I open this first rule, that is called 12FU firewall. Okay? We say that in that rule, I use chain input. We don't need address checking, but we check only the interface where the packet is going in the firewall. It's the same for all the rules that are in the input. So we have, see that. I don't have in use in this configuration the name of physical interface. Then, this is quite simple. This is also a standard rule that is doing all the rest traffic. And in the action, we are dropping the traffic and doing a log, if you want, to make sure that if you drop a packet, you know why, where. Is most important in troubleshooting. Then, in the forward, we can see a lot of many interesting things. The first part is the same, accept, establish, related. Then we have this kind of definition. At this time, we have a jump to ICMP check. So, if the packet, let's go to say this, is kind of packet is ICMP, there is a simple jump. Then, elsewhere there is a definition how to check this ICMP. It's not simple. We can we go to show that. There, you have where is ICMP? Check. The second one, okay, sorry. This is a complex rule. I wrote this one once. Only one time I wrote this kind of rule. Then I use, by the way, they do see. Only a jump. Because in the rule, in the check, I checked all the ICMP traffic, there is no way to return back to the rules. We see another kind of check. The SSH, this is, wait, okay. This is brute force check. If someone in the world try to force the SSH connection, the first time, well, the address is added to one list. If the address is in that list, is the first back, yes. Just to say that, okay? The action is what I say in the presentation. The IP address is added to the SSH stage 1 and forward. Each time a new packet goes to the RouterOS device, the packet on the SSH port go to. And the last one was this one, the drop, or better, this one. And why this is SSH backlist. So I added to one address list that is definitely also the time that you see there is 10 days. This is common configuration, but this at the end we have a return. So if the packet is not dropped or classified by this kind of rule, the first drop but goes through all rules, the last one go back to the point where we call the jump. This is a return. If you see that, I can use this kind of configuration everywhere on the filter definition. It's not important where. If you go to one of the singular definition, La12F2, this one, this is recorded here in the input queue, in the input chain, here, there. We check if packet is going from the one interface, and then we go to the chain 1 to FW. Then the chain do the rest. This kind of configuration here in the presentation there is all the code, so you have all right, is what I say at the start. We have a complex configuration, we have many interfaces, many IP addresses. There is a specific configuration for each interface, but we don't write once in the configuration the IP address, once the network interface. We use IP addresses only on destination NAT, only on the action part of the rules. Then, for this year, I have a request. The last year was good, so this year I try to. I need complete IPv4 firewall because there are some function missing, policy routing and other things. And we need to complete this kind of optimization, something like objects, IP addresses and ports, defined in the same way like address lists and interface lists. So we can write rules without specify IP addresses. This is most important for IPv6 because the complexity of the IPv6 addresses. There is some question?
question about the layer 2 firewall. You have to